So the other thing I need to talk about electromagnetic waves is that talking about energy on the Earth, there's only really two sources of energy. We talk about coal, we talk about oil, talk about all that other stuff. In all honesty, there's only two sources of energy that we really tap into. The first is light, is radiation. You have the biggest reactor in our solar system, the sun, generating tremendous amounts of electromagnetic radiation and delivering it to the surface of the Earth. Okay. We have vegetable matter on the Earth that's consuming that light, and with some other elements transforming into sugar. Okay. So the light energy comes in and transforms, or gives the plant enough energy to transform some low complex molecules into high complex molecules. Therefore, storing energy. Eventually that plant matter dies. Give it a million years to compress and turn into coal, turn into oil. But that's where that's coming. So most of our power, even if we're talking biomass, or if we're talking superalgae, most of our energy that we want to use on a daily basis is coming from electromagnetic waves. And the reason that's true is because unlike mechanical waves, so if you use the example of mechanical waves, like sound needs air to travel. As a matter of fact, sound through more rigid materials. So if you're speaking through rock, it'll actually travel faster through that rock than it would into the air. Now light is different. Light doesn't need that medium. It travels, from the sun to the Earth with no material in between it. I mean, there is particles out there in the universe. There's helium, hydrogen, all that is floating around in there. But there's no medium in between. So all of that energy not all of it, only a small portion of the energy from the sun gets delivered to the Earth, but that energy has been stored in plant matter, and that plant matter has eventually been turned into coal and oil. As a matter of fact, I think there's a book out there called The Last Days of Ancient Sunlight, where they're talking about consuming this energy that has been stored on our Earth for millions of years, and now we are consuming it at an incredibly alarming rate. I mean, you're talking total consumption maybe within 100 years. I mean, that's kind of scary. It takes millions of years to build up that material, and now we're going to consume it in a matter of 100. The other already talked energy, that's between bonds and particles. Arguably, because we could talk about the formation of heavy atom, the sun, we can argue that the sun is receiving the energy on the Earth, but we typically think of nuclear energy being something entirely different from solar energy, light energy, which it is. And the sources of those energies are not necessarily connected. The truth of the matter, they are, if you talk about astrophysics. But those are really the only two sources of energy that we have, is this nuclear energy and the solar energy. So, 90%, if not above, of the world's energy supply is delivered from solar energy. Every gallon of gas, every ton of coal, every barrel of oil, that's all coming from the sun. Even tons of biomass is delivered from the sun. So, think about calories, all that energy that we consume just to keep ourselves running. All of that is solar. Only a few examples that are using nuclear energy as a power supply. Nuclear reactors, that's about it. Okay? So, that's the other thing I wanted to say about electromagnetic waves, that in which we onto our planet. Okay? Cool?